This is problem 220 from chapter 12. The boat can travel with a speed of 16 kilometers per hour in still water. The point of destination, that's going to be the red X here, is located along the dashed line. This is at an angle of 70 degrees from the horizontal. If the water is moving at 4 kilometers per hour, this way, determine the bearing angle theta at which the boat must travel to stay on course. Okay, I want to figure out what this 16 kilometers per hour is. I also have this equation to use here. They gave me the velocity of the water, so presumably that's either going to be VB or VA in my equation here. And the other one will be the velocity of the boat. The 16 kilometers per hour, I want to know if that's the velocity of the boat or the velocity of the boat with respect to the river. So if the motor on the boat is turned off, the boat would still be moving with the river and the relative velocity would be 0. And if the boat is going in the same direction as the river's flowing, so let's do that over here. So let's say the river's going faster than 16 kilometers per hour, just to figure things out here. So let's pretend in this case the river's flowing at 20 kilometers per hour. If the motor was turned off, then the boat would be going with the river at 20 kilometers per hour, and so the boat would also have a velocity of 20 kilometers per hour, and in this case the relative velocity between the boat and the river, so this would be the velocity of boat with respect to the river or the water, is 0. Well, this can't be the velocity of the boat, because if it was, in this case, this is faster than 16 kilometers per hour, but it said it could travel at a speed of 16 kilometers per hour in still water. So this must be the velocity of the boat with respect to the water. Okay, so then if that's the velocity of the boat with respect to the water, in this situation here, the motor was turned off. Then if you turn the motor on, you're going to go even faster, as long as the boat's still going in this direction here, because you're going to add something to the velocity of the water. Okay, so we have the velocity for the boat, the velocity for the water, and the velocity of the boat with respect to the water. So the boat is going to be B, and the water is going to be A in equation 1234. So that is the velocity of the boat is equal to the velocity of the water plus the velocity of the boat with respect to the water. And if you said the velocity of the water with respect to the boat instead, and made this the velocity of the boat and this the velocity of the water, you could still solve the problem. So don't worry too much about that. So let's plug things in. So this was just a little side note to figure things out. So these values we're not going to use for the problem. So the velocity of the water is pointed this way at 4 kilometers per hour. The velocity of the boat with respect to the water, what direction is that supposed to be going in? Let us draw a vector diagram to help us figure things out here. So I know the velocity of the water is pointing this way. And then we're going to have one vector going in at an angle theta. This angle is theta. And I have another vector going at an angle of 70 degrees. It's this vector that I add to the velocity of the water to get the velocity of the boat for my equation here. So this one is the velocity of the boat, and this one is the velocity of the boat with respect to the water. Let's go back to our imaginary situation here to make sure everything works out. Okay, this is just in one dimension. What was I doing here? They're both 20. Okay, and then let's say we make this one 16 kilometers per hour now. So the water's going this way, and then I would add the 16 kilometers to that, and then I get something even bigger for the velocity of the boat. That makes sense. If this is 20, you turn on the motor, you go at 16, now your boat goes even faster. Okay, so that looks good. VB should be the resultant vector, and it is. It's smaller in this case because you're going against the direction of the water. Okay, now what is it that we are looking for? We are trying to find theta. Well, let's stick with the vector diagram that we have here, and let's put in the magnitude of the vector. So I'm going to redraw this, but it's the same triangle. This side is 4. The velocity of the boat with respect to the water is 16. And this angle here is 70 degrees. And we're looking for this angle here, which is theta. If we think a little bit about the angles that we have, if this angle here is theta, then this angle here is also theta. If this angle here is 70, you can make a right triangle like this. So if this angle is 70, then this angle here would be 20. If this angle is 20, then the angle here is 180 minus 20, so this is 160 degrees. I think I need to draw that again, maybe a little bigger this time. Okay, so this angle here is 160 degrees. This angle here is theta, and this side is 16, and this side is 4. We have a triangle. We know 3 things about the triangle. We know 2 lengths and an angle. We want to find another angle. We should be able to do this. And one way we can do this is using the law of sines. There are other ways to do this, so if you want to try and solve it another way, you're welcome to do that, but I think the law of sines method is probably the easiest one to use here. So if we take 16 divided by the sine of 160 degrees, that is equal to 4 divided by the sine of this angle. Can I say what this angle is? So the angles in the interior angles for the triangle should add up to 180. So we have 180 minus 60, that's 20, so this would be 20 minus theta. I want theta to be in my equation because that's what I'm looking for. Okay, so then we solve. Okay, so we have sine of 20 degrees minus theta is equal to 4 divided by 16 times sine of 160 degrees. You can plug that into your calculator and you should get 85.5. No, you should get 0.0855. And then 20 degrees minus theta is equal to the inverse sine of this, which is in degrees. No, it's not. It's just a number. Okay, and that will give us 20 minus theta. This is in degrees. That's 4.91 degrees. And so finally, theta is equal to 20 degrees minus 4.91 degrees. And that gives us 15.1 degrees for the angle theta. And that concludes problem 220.